And we're live.
Yes, we are live. Let me just move this banner. Hello, everybody. Welcome to Deep Learning Design Pattern Study Jams, session number 2. We're very excited to have you here today. I'm Margaret Mina-Reed. I'm the lead organizer of GDG Seattle. And here we also have Yingqi Ling, our other co-organizer, to help out tonight. And we have Andy Ferlitsch there, who is our main instructor for the study jam. So GDG Seattle, for those of you who are new, GDG Seattle is an inclusive community where everyone is welcome. And this is typically how we will start our event. We welcome everyone and talk about our code of conduct. So our motto is be excellent to each other. If you see or experience anything different, please contact us, GDG Seattle organizers. Tonight, agenda, Andy and I are going to have a brief intro of us again, just for those of you who join us for the first time. And then we're going to quickly take a look at the topics of the session 2, that what you should have studied. And then we'll move on to Q&A. So we will be learning through a Q&A format. Hopefully you have all studied. And then we will wrap up with next steps for session 3. By the way, if you have any questions during the session, please post to YouTube live stream, or you can post to that Google Doc that we have put on the live stream. So answer the questions there as a comment. That way we can keep track of the questions and answers. Anytime throughout tonight's session, you can feel free to use the hashtag and Twitter handle at the bottom of each slide. Now, please welcome Andy again from Google Cloud AI Developer Relations Team.
Yeah. Hi, everybody. Margaret's already said my name, so I won't repeat it. My role at Google Cloud AI, I'm in developer relations. That means I'm external facing. So you'll see me in all kinds of places, at least before things went virtual. So I'd be at conferences. Sometimes I'd be loaned as an adjunct professor to give a lecture at a university, do meetups, training, workshops. And I work with some of Google's largest enterprise clients, their engineering teams, to overcome large-scale production, going AI into production. My expertise is computer vision and deep learning. I was formerly a principal research scientist for 20 years, specializing in imaging. I have 150 US patents based on my research, and I'm currently writing a deep learning book to be published by Manning. And the series that we're here is based on the book. Back to you, Margaret.
Thank you, Andy. So as I said, I'm the lead organizer of GDG Seattle, and I'm also a machine learning GDE, which stands for Google Developer Expert. I lead GDG Seattle as well as Seattle Data Analytics and Machine Learning. Currently, I'm a machine learning engineer and a researcher working on AI for art and design. So back to you, Andy.
Okay. Yeah. So, if you were in that first session, the introductory, or if you weren't and read the description of this meetup, we wanted you to go study ahead of time. And that study is based on the novice section of the book that helps you get prepared for, the really full-scale deep learning. It's an introduction. And so there were 3 sections in there. There was one on deep neural networks, and we'll take questions on that first. The second one was an introduction into convolutional and then residual networks. And then finally, setting the foundation of how to do training. So we can go ahead and move on to the next slide. Okay, So we're going to do this sort of in sequential order instead of hopping around. Okay. So I wanted to start off with chapter 1 and answer questions that people had on the deep neural network section. And I kind of leave it up to Margaret there to moderate.
All right. So I saw someone is typing in the Q&A doc.
Yeah, so there was one here about the training foundation. I wanted to wait, until that section.
Okay, yeah. So any questions about the deep neural network? I don't see any question about the deep neural network.
Well, I tell you what, we don't have to follow this format. We'll just answer questions as they come in. So we have one here related to part 3. They had actually, I guess other people can see this document. Okay. And so they're showing, an accuracy and a loss. And they're asking if this is a good generalization between a good balance between generalization and overfitting. Okay. And if you first look at it, you probably would think that yes, but there's some little subtleties here. So, the difference between the validation accuracy and the training accuracy is really small, as you see. Okay, 98.8 and effectively something that's probably 9999. Okay, a percent or a 1.5% difference. We expect that. Okay, but what you can see here is around probably the 10th epoch, the validation accuracy seems to have plateaued out, but the training accuracy is going up. And that's kind of suspicious. So what I would look at is further down at the epoch loss. Okay. And you notice that while around, again, actually it's more around epoch 5, my loss continuously is going down, but in a very flat and plateau layer on the training data. But the opposite is happening on, for some reason, here it is, the opposite is happening on the validation data and it's going up. And that really means that I'm overfitting now. Okay. So these last few epochs here, that last little bit of accuracy, I'm really just memorizing stuff. And the more I'm memorizing, I'm just widening the gap here on the validation data. So I would probably have stopped around number 5. Okay, so the next question I see here is somebody saying, thank you for a great lesson. I appreciate that. Sounds like I don't know what you mean when you watch all of YouTube lessons, if it was just the primer section or our entire series. Okay, and that series is growing. And you're asking if we plan to do sessions on audio and text. And at this moment, we plan only to be doing computer vision. Okay. It would probably be best, because I can't think off the top of my head, to make some to look up some resources, and Margaret can post some recommendations on learning resources for like text or natural language processing and structured data. But on audio, we actually solve audio as a computer vision. Okay, so any type of signal data, the way we solve that today, I mean, traditionally we would have solved that sort of more like longitudinal or time series, but we found that we can actually, project it as a chart, and that's an image, and we can train models that way.
Yes, to add on to what Andy is saying, that if you go to TensorFlow.org, actually TensorFlow.org has great tutorials on text and some tutorials on audio. There are not a whole lot of tutorials on audio. Actually, if you also look under the TensorFlow Lite section on tf.org, I think there are also samples on text and audio as well. So are there any other questions?
Okay. Well, we have somebody here who says they're joining for the first time and they want to know how to access the materials. Maybe you could show them how to get to that link.
Oh, yeah. So I'm going to skip forward to this screen.
Okay.
So I have all the screens here. You can see the link here to Andy's primer, which is on GitHub. And you can watch all the videos and do all the exercises and join Slack channel. So you're only seeing it here. What I'm gonna do is I'm gonna copy the link. Let's see. Oh, that's.
Okay.
Yeah, I just send the link of the primer, and I'm gonna send the link of the video and also the exercise. Also, if you have joined from our meetup, if you heard about this from our GDG Seattle meetup, you will be able to see all the links because I included all the links on meetup. Perhaps you didn't. Then, Inchi, do you mind just post our meetup link here, please? Like, link to our session 2 meetup. Thanks. All right, so those are all the links there, and the last link I sent is actually the study jam. So we expect you to actually study. Like you read the material, you watch the videos, because Andy actually did a recording on all those materials already, and then you can also do the exercises, and then you can join the Slack to help each other out and ask questions. So all the sessions, we have 3 more sessions. These sessions are live Q&A. We expect you to study ahead. For example, for today's session, we expect you would have watched the deep neural network video that Andy made, and then done the workshop, and then watch the video on convolutional and residual network, do the workshop, and then same thing for training foundations. Then, you come here, you say, oh, your questions probably should be related to these 3 lessons. I call them lessons or sessions or whatever, but they are designed for this particular Q&A session. Okay. So are there any other questions? I'm going to check the doc.
Yeah. If there are direct questions, why don't we do this? Let's go back to the chapter 1, the deep neural networks. And we could always ask people what their opinion, what they thought of that chapter, how helpful it was, or where they thought there might have been gaps or it could be improved on.
Yeah, sure. I mean, we can go to the first one, yep. The deep neural network one.
We just have a question on chapter 1.
Oh, okay. Do we have one?
Is there a good rule of thumb way about determining the number of neurons of each layer to start with?
Not really. Okay. I mean, for example, people kind of learn. For deep neural networks, we really only use that in tabular data, and it's still kind of a guess. So, you typically start, most people, if they're doing some kind of macro level network architecture research on a traditional neural network for a structured data problem, they usually start with 2 hidden layers. Okay. typical sizes I see people try on them are going to be like 256, and then they're going to double 512, 1024, 2048. What you're looking for is getting enough capacity to learn to learn from the data set to predict it, but not so much overcapacity that you can memorize the data set. So you're trying to find that sweet spot. Hopefully that answers the question. Maybe Margaret, you want to offer some insight?
Yes. So there's really no rule of thumb like how many layers, but I can't remember. I think Andy, on your GitHub, you have a lot of examples like the Model Zoo. You are talking about different famous networks such as MobileNet, ResNet, these networks. So one way of learning how to do the architecture, Andy's book is about the design pattern, and design pattern is also a lot about how to structure your network, right? Not so much about how many layers, but as you look at all these famous networks, you kind of get an idea of how to structure your network, or in fact, I will say, as a beginner, you study them, you look at these network architecture, and you kind of learn like each network kind of network has sort of a purpose, right? Okay, such and such a network is focusing on the accuracy, such and such a network is lighter and therefore smaller or run on mobile, and have these different kind of architecture. Also, I would say a lot of times, I think, Andy, you're going to cover later on about transfer learning, right? So a lot of times people will also rely on transfer learning of a pre-trained model, instead of actually defining your network architecture yourself. So that could also help you.
Okay.
All right. I found here's another question. I'm going to show this question.
Oh, isn't there one right before it?
Yeah, sorry, I skipped one. Yep. All right. What is the best way to start implementing a paper, for instance, a new deep learning architecture? That's a great question, Andy.
Yeah, well, papers are going to go to either journals or conferences, okay? And journals, though, are highly selective or discriminatory. You could say who they're going to take a paper from. So it's really, you're going to have to be already well established. And it's going to go through a heavy peer review. So most people, the very first paper they get published, it gets published at a conference. Okay. So you find a conference that has put out a call for papers, and you produce, you write your paper, you submit it. And if they accept it, you're going to go up there, do a presentation, and they're going to publish it on your behalf. After you do that a few times, you sort of build that credibility that you can start going to like the big formal journals.
Although, Andy, I don't think the question is how to write a research paper. The question is how to start implementing a paper, i.e., I am a beginner. I just started learning about neural networks. I read about a paper about XYZ network or some state-of-the-art thing. How do I go about writing the code based on their paper?
Yeah, I understand what you're saying now. And I apologize, I misread it. That is a difficult challenge. For me, it's not so difficult because I'm a research scientist. I've written papers, read papers. I read stuff from research people my entire career. So I kind of know the speak. And I would understand that somebody who's just a software engineer trying to want to read one of those papers, it's practically impossible. And everyone invents their own terminology. You go to the next paper, they're talking about some of the same things, but they got different words for it. And they got different charts and different representations. And you got all this stuff to decipher. Okay. So what I would do is you really have to rely on people like myself and many other people like me who are very experienced with research and research papers, and we convert it in what we call software speak. And that's how I like to actually describe my book and all these lessons. If you've noticed that no matter what type of network I'm showing you, state of the art that came from a paper, I'm using the same terminology, the same representation, the same style of description. So I'm doing sort of that
standardizing
for you.
Yeah, so I want to add a bit to what Andy is saying. Well, first of all, if you, I highly recommend this website called the Papers with Code. And if you go there, you can search for paper, and then likely it's going to have a bunch of code to go with that paper. And you will see, a bunch of, sometimes there's no code at all, a paper just come out. But a lot of times you will find all the implementations, which is really nice. You will see all the, the PyTorch, the TensorFlow implementation there, and the popular ones, they ranked by the stars, right? So that's a good way, because you look at how other people implement the paper. There's like 5 different ways of implementing, and you can try go tweak it. Like I found, I actually mentioned this to Andy. I said, I see a lot of the state of art papers are in PyTorch or still in TensorFlow 1, right?
Yeah.
Try
older ones in Cafe.
Try upgrade it from TensorFlow 1 to TensorFlow 2 and try implement the paper in Keras if you see it only in PyTorch. It's a good practice for you. And I also mentioned to Andy, I said, Andy, your book and this whole study jam is all about neural network architecture. It would be really great if we come up with examples to just show those too. Like, here's how going from PyTorch and we're going to implement in Keras, or TensorFlow 1, implement TensorFlow 2. And I will highly encourage all of you. I know it's still very early, like we're in session 2, but really this is our first session to talk about all those basic neural network thing, right? But I encourage all of you to try do those paper implementation based on what you learn from this study jam, Andy's video and Andy's GitHub and the workshop.
Yeah, I just want to iterate on, it looks like named Eric Trum, his comment. Yep, just read a bunch of them to start. That's how I started. I was an imaging scientist, but it was all before deep learning. Okay. And so when deep learning came along, I was just like everybody else. I may have had an advantage being an imaging scientist and new research, but I was still starting from scratch. It was early 2017. Obviously, deep learning had been around for a while. And that's what I did. I just kept reading research paper after research paper. Those first few ones, I felt like I was banging my head against the wall, all this inconsistent terminology across papers I wasn't familiar with. I'd read the code, like those early implementations, 2014, 2015, 2016. They're not computer programmers or people who came up from statistics and that. Portable Go is terrible in many cases to read. At the beginning, it was really brute force.
So Andy, I think later on I'm probably going to share with all of you in our study jam Slack channel. I highly recommend you all join. In the Slack channel, I'll share with you a couple blog posts I found about how to read research papers, and different people have different styles of reading. I have my own style of compiling and collecting and reading them because there's just so many of them, right? And another thing is, Andy, I am thinking just off the top of my head, maybe we can do one sessions or pick one of the sessions to do. I've seen people done this before where we spend some time just to read a paper and compare, here's the paper and here's the code implementation. I thought that would be kind of interesting as well. All right, let's see. Somebody said, thank you much. Great answer for all. We're waiting for the book. Great. Good to hear. And I also want to show, this is the website. This is the site there, Papers with Code. This is where you can find all the state-of-the-art papers along with all the code implementation, hopefully. Some of them don't. And then here's another question. Chapter 1, is deep learning limited to solving linear separable problems. Can you show some model names that are suitable to solve nonlinear-like problems?
I'm not exactly sure. I mean, I know what they mean by linear separability. Okay. Matter of fact, problems that are linear separable in presumption could be solved through linear regression. Okay. Deep learning, on the other hand, specializes in problems that don't have that clear separation, that you can draw a line. Everything on this side of the line is A, everything on this side of the line is B, or a hyperplane in a multi-dimensional space. Everything on this quadrant over here is A, and this quadrant here is B and C. What deep learning does is it learns correlations between, you could say, fragments of a linear space. Okay, and sometimes the way I explain it is, think about a simple model about age and income, right? Okay, and you would think that as it goes up in age, income kind of proportionally goes up, and there'd be a linear correlation. Well, it's not really true. You know, when you're a young child, your income is your allowance, right? Okay. And then you become a teenager and your income changes. You know, it becomes that job you get. And then you go to college and your income goes to zero. Okay. So you have this linear break. You get out of college, your income starts to go up steady, 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 steady. You retire and then it flattens. And those are different linear segments. And what deep learning does, it learns how to partition that up and then find that linear separability within those segments. So it's actually doing both. Hey, did we lose Margaret? Okay, you're back.
So there's one more question. What's a proper location to insert the dropout layer in between dense and or before dense or after?
Okay. It's not such a common practice anymore, but when it was a common practice, okay, it was inserted before the last dense layer.
Okay. Sorry, I was distracted when you were talking about linear answer. Actually, I thought the whole point of deep learning is that deep learning can solve nonlinear separable
Right,
problems.
that was my point.
Oh,
but
okay.
by discovering the segments that have linear separability.
Yeah. Also, let me just back up a little bit. Okay, I know there's some other comments and questions, but I'm gonna just show something here. There was a comment saying, yes, that would be an interesting session discussing paper and code. So that was, while I was talking about having a session or have a snippet of reading paper and discussing the code, I thought that's very appropriate in terms of discussing the whole study gems about model architecture, right? Okay, so I am going to go down to the question called, are you considering to including the book Models Interpretability? Sometimes it's kind of hard to explain why the model works just with the accuracy.
I would say the next session, because we now move into the beginning of the junior data scientist session, we do start to dive in more inside of why this works and how it works and what's happening inside of the model.
I want to add to that, Andy. Yeah. I think, again, I'm going to put all this information in the Slack study, the Slack channel. Doesn't GCP Google Cloud also have a new product called Explainable AI?
Yeah, Explainable AI, AI, or what's it? I think they also call it What If.
XAI. So that I check out there's some links and documentation. It's fairly new, but it has explainability for like image classification. Some of the problems. Some of the type of.
No, I would think, and they're closely related, interpretability and explainability are slightly different. Okay. To me, interpretability is more of an engineering thing. For me, as an engineer, to understand what's happening inside of that model and where it's happening. Okay. Explainability to me is more of a business thing. I want to be able to explain to decision makers or to the customer why and how the model made a decision on a specific input example.
Okay. There's another. Well, someone said the thank you, and yes, I'm not sure what that means to which comment. Maybe the paper with the code, I think. Anyway, so it means there should only be one dropout layers to be included before the last layers. I have seen multiple dropout layers in between the layers. Will that be wrong?
Okay. It's more what you could think about trial and error. So, state-of-the-art models went through a certain progression. So you can kind of start 2014 and 15 and then 16. And you watch how things progress and what was the last thing everybody was doing. So, early on, yes, people were putting dropout layers near the beginning of the model. And then later, when models started to form patterns, and we haven't really gone into that, and form groups, they would put a dropout layer at the end of every group. And then in the final state-of-the-art models that still use dropout, it all got reduced to a single dropout in that very end of the model, just before the dense layer that did the classification. But you do see some variants near the end there, like I believe a squeeze net, for example. Actually, instead of using a dense layer, it uses a convolutional layer, and I believe I put the dropout between the convolutional layer and the softmax activation function.
Okay, great. I don't see any other questions. Oh, somebody said dropout. It's about it's about not overfitting. That's all it matters. There are many ways to do it. Yes, that's a good
yes,
point.
and
Yep.
that's considered.
This is why we do dropout.
Right. Yeah, and that's considered even though I introduce it in the primer here, because that was sort of our first method of preventing overfitting, or more what I call memorization. We don't want to memorize the data, but that technique has been very modernized. We call it regularization, and there are many new regularization techniques that are far more effective, and that's why in today's models you won't see a dropout layer.
Okay, so at this time it's almost 7:45. I want to get to the to talk about the expectations for the next session. This has been a very good Q&A session. By the way, for those of you who asked the question on the stream, the video stream, the whole Q&A has been recorded. However, the chat on the side is not recorded, and I feel like it would be great if you don't mind, for those of you who actually ask questions, just put your questions, copy paste your question, put them into that doc that we sent out earlier. That way, for people who have missed it, or it's really nice to just read through, okay, for this session these are the questions, right, without having to watch the whole video. So now I'm going to actually move on to the next slides. So I actually already mentioned this earlier, but I want to reiterate for the next session, especially for those of you who are new. Okay, you should definitely read upon the materials on the GitHub and watch Andy's videos. He has made a recording, and do the exercise before you come. Join the Study Jam Slack so that you can ask questions, and we will also be posting some materials and links based on the discussion we've had today. And then bring your question to the Study Jam session for next time, right? And what is next for the session 3? There are 3 topics that we expect you to study. One is deep neural networks.
Oh, wait a minute. It looks like you got the wrong slide up here. I thought we updated this slide.
Oh, Let me see. Just a second.
Because I remember in my copy, did it get changed?
Let me just refresh.
Okay. Yeah, my copy shows it updated.
Yeah, it's okay. I'm refreshing my slides, so probably because it didn't refresh.
No, Danny.
Somehow it's like really, really slow. Andy, do you want to share your screen? I can stop sharing mine and you can just
let me see.
share your screen.
Okay. Share screen?
Yeah.
Okay. Okay.
Margaret, do you want to also retract the banner?
Oh, yes.
Okay. Can you see my screen?
No.
Not yet.
Oh, you can't? It says I'm sharing it. But you don't see it?
Margaret, you might need to switch the right layers.
Hang on. Just 1 second. Let me just get to this. Okay, I got it. Let me present again and share my screen.
Okay, then I'll stop.
Yeah.
Okay.
So it's taking a bit of time to load. I don't know why it's taking so long to load.
Well, while it's loading, I can just sort of give them a heads up. So you're going to go for the videos, you're going to go to the playlist for junior data scientists, and you're going to watch the first 3 videos. You get to that? Let's see. Oh, there they are. Okay. Yep. So this is a point where we take you from the basic concepts of deep learning and start you on the road to modern deep learning. And today, in modern deep learning, everything's based on a design pattern. Not much different than as being a software application writer, and you have a certain type of problem and you apply a certain design pattern to solve that problem. So the very first video, we cover really a very basic design pattern used in deep learning. It's a procedure reuse style design pattern, and I show you how to apply it to several early state-of-the-art models. Okay, and then we're going to look at other patterns that evolved, different ways of connecting. Up to this point, we would have talked about what are called deep neural networks or deep convolutional neural networks, and also neural networks that have the residual blocks that have the identity link into it. So we're going to talk in the second one, show you different patterns, those connectivity patterns. And then in the third one, like I said, we had been focusing all this time on going deeper, what to do to go deeper. Convolutional models also went another direction and experimented with going wider. And we'll cover those models, how they were designed, how to code them using the design patterns and their pros and cons.
Okay. So, well, I think that's it, right? We thank you everybody for joining us, and I will post I know you're all here, but I'm gonna take the link and put it here for those who missed it, and then hope you have fun studying, and we will see you on June 4th. Bye, everyone.